Children have started using digital media on a regular basis. This causes a worry about how much time will be used on the playground. As a solution, a digital game could be implemented onto the playground in an attempt to have children to continue playing on the playgrounds. This will combine their interest of digital media and physical interaction. This led us to the following problem. Can you make a playground more entertaining by adding a camera? After investigating children's play habits, we came up with an initial problem formulated as: how does digital play affect children's social interaction? We learned that children have certain preferences when it comes to playing. Among those, the necessary values are: give motivating feedback while they are playing, creating opportunities so they can define their own goals and rules, have social player interaction by designing opportunities to collaborate and compete using interactive play objects. With this in mind, we had to find the user interface that children prefer to play with. We learned that tangible user interface was the most entertaining, so we chose this for our game. When merging digital and physical play, we found that we should focus on dealing with uncertainty which can arise in players' actions and positions because of the limitation in the technology. Informing the player of the limitations were also an important factor, as well as minimizing the uncertainty through the design of the game. In terms of hefting domains, we have to consider how a designer needs to represent in both the physical and digital work. Based on our background research and our initial problem description, our final problem formulation is: how to make a game for children that utilizes visual computing in a way that affords open-ended play, physical cooperation, and provides good mapping through the use of a tangible user interface. We also found our success criteria for the game, which are: incorporate open-ended play, incorporate cooperation to afford social interaction, use tangible user interface to provide better mapping between the digital and physical play, and utilize visual computing. To initialize our design, we used a method known as 10+10, where 10 different solutions based on the success criteria were designed. Some examples are warships, laser game, math block breaker, and many others were thought of, but we chose laser game as it fulfilled all criteria best. We iterated multiple times, first the ways of playing the game, and then how the levels should be designed. We wanted to specify if we wanted a normal laser game, a tile laser game, or a color laser game. And here the normal laser game was chosen as it matched our criteria better than the others. Our success criteria made it clear that lots of minimum implementation requirements were needed, and those are: making a laser, reflect the laser, identifying blockers and mirrors separately, ignoring players, place targets randomly within a given area, register contact between laser and targets, point system, and creating a playing field and a reasonable response time. The method we used for the evaluation was testing our system to see if it fulfills our implementation criteria and calculating the response time of the program. The test for the response time was split into two tests, one using our own defined functions and another using the OpenCV functions. We recorded the action in slow motion to calculate the response time. With our own defined functions, the response time was at 8.8 seconds and OpenCV functions at 0.12 seconds. According to Jakob Nielsen's response suggestions, our own defined functions did not withhold the acceptable response time, which is 0.1 seconds, the user does not feel the latency, 1 second, accepted amount of wait time with no task, 10 seconds, accepted amount of wait time with another task in hand. In conclusion, the project found that an image processing system should be sufficient to implement such a game that affords open-ended play, physical play, and good mapping through the use of a tangible user interface. However, it was not possible to evaluate if the prototype affords open-ended play, physical play, or good mapping through the use of a tangible user interface because there was no user test.